semiconductors for energy efficient devices. So let's see the overview of this topic. So where we are going to apply this semiconductor technology is for the industrial sectors and telecommunications. So where we want more efficient power conversion devices. So in order to reduce the CO2 emissions, which is the impacting our globe today, so we are going to apply silicon. Instead of silicon based semiconductors, we are going to apply wide bandgap technology, that is gallium nitride semiconductor. So why we are going for this? Because in the silicon based power semiconductors we have some limitations, that is it is operating frequency and speed, and also poor high temperature and low current performance. So these are the limitations. So we are going to apply wide bandgap semiconductors because they are becoming more popular in many applications nowadays. So we are considering the gallium nitride semiconductor for future energy efficient devices and electric vehicles. So this will give many benefits to telecommunication and also automotive technology. So basically Sweden based startup actually started this concept and they are working on this technology. So next, the gallium nitride power semiconductors have many advantages. It reduces the size and weight of the component so that it will give more efficiency, and also 4 times smaller and lighter, and also 4 times less energy consuming. These are the advantages. So we can apply this gallium nitride semiconductors. So and also it has zero reverse recovery, which reduces the switching loss. Because when we are coming to telecommunication application, it need to reduce the switching losses so that we can apply for higher frequency and quicker switching rates, and also decrease the switching turn on and turn off losses. So it will give volume reduction of capacitors, inductors and transformers, which will be applicable to electric voltage charges and then electric vehicle charges and then inverter. So this is the overview and background of this case study topic. Now we are going to discuss the challenges present in this topic. Discuss among yourself and then give your ideas. Thank you.
Now I am going to discuss about next generation semiconductors. And the next generation semiconductors, energy efficient semiconductors, will help them to create a new solution for a sustainable futures. This means less carbon dioxide emission and thus improvements in global warming in the long run. The prediction from many agencies indicates that electricity will use and it will increase the more than 200 kilowatts by 2050, a high number that requires attention at the design level, as semiconductor substrates or rather wafers have the goal of controlling the electrical current and the performance of the entire end device. Round wafers are cut into postage stamped size, encapsulated in microchips containing millions of transistors.
So now I am going to discuss about the technology used in this case study. So the rise time and demonstration facility Pronance offers a variety of infrastructures to help speed up the startup testing without having to spend a lot of money or expenses on this equipment. So the nanowires are manufactured using Pronance metal organic chemical vapor deposition technology to produce thin gallium nitride layers on the silicon wafer. The wafers are treated and confirmed at very low energy to produce patterns in which gallium nitride nanowires may grow and then coalesce together to produce high quality thin epiaxial layers. Then the wafer is then examined under an electron microscope to check its quality. The main goal is to have a large wafers or to produce thicker vertical gallium nitride semiconductors. So according to the hexagon, 2 to 4 micrometer thick layers are common today. So the thick gallium nitride layers will enable devices with higher voltage ratings, so which will be important for addressing 900 to 1200 volt device markets. So it would be also enable vertical device design, which would bring benefits such as decoupling voltage, scaling from device footprint, So Exagem aims to developing high quality gallium nitride on silicon for 1200 volt device design and licensing the technology to industrial partners.
So now I am going to discuss about the semiconductor processing. Actually, the very first stage of semiconductor processing is that the manufacturing of transistor, where metal organic chemical vapor deposition methodology is performed in order to manufacture transistor with a large band gap. So specific gases flow at specified temperature and pressures across the surface of substrate in metal oxide semiconductor vapor deposition system. The top layer are developed into a crystalline structure in this way on atomic layer at a time across multiple layers. The technique is known as epitaxy or crystalline growth. So in order to create 3D nanostructures such as nanowires, so the layers can be grown over the full surface of the substrate or over selected sections of the substrate.
Thank you students for discussing your ideas on the challenges and implementation ideas of case study topic gallium nitride semiconductors.